Hi there, ladies and gentlemen. My name is Merrill Cook, Content Marketing Manager at Diffbot, and I'm here to show you 3 potential ways to scrape web data using Python directly from a Jupyter Notebook. These are super simple examples that you can follow along line by line with and have your own basic Python web scraping example up within a matter of minutes. But perhaps most importantly, particularly if you're going to scrape at any scale, we'll cover some of the trade-offs between these 3 extraction methods. At the end, we'll also cover some basic best practices about web extraction. To start, we'll look at 2 of the most popular roll your own Python web extraction options, which are Selenium and BeautifulSoup. And then we'll dive into the same extraction example using a newer extraction method, which is one of Diffbot's AI-enabled automatic extraction APIs. We'll be looking at iherb.com, a product category page for all 3 examples. I have it pulled up on my screen, and as you can see, the category is Manuka honey products. Depending on who you ask, Manuka honey is a miracle cure, just nice honey, or just a health good fad. iherb.com is perhaps the largest supplement and health food store online, and you can hopefully see why extracting data like availability, reviews, sale pricing, product links, and more could be useful for content, market intelligence, competitive intelligence, e-commerce, and even machine learning applications. A broader note is that well-done web scraping can allow almost any web page on the web to become your database. This is extremely powerful, whether for a one-off data gathering exercise or to power a nearly live data app or dashboard. To start, we will assume you have Python installed, and if you don't, just head to this link and download the proper version. If you're on Windows and have opted for Anaconda instead, the commands for installing modules for each of these examples may be slightly different, but should be pretty easy to figure out. The next thing we're using are Jupyter Notebooks. If you're an analyst or data scientist or data science student, you've likely used these before. If you're sort of a DIY creator or hacker type, they're honestly pretty straightforward. You can head over to jupyter.org/install, what I have up on the screen, and there are instructions based on whether you have Anaconda or pip. Once you have a notebook installed, you can run a notebook by navigating into the folder in which you have a notebook or you want a notebook to live within a command line interface, and all you have to do is type Jupyter Notebook. A notebook should automatically start at localhost port 8888 by default, at least. So all of these examples are in notebooks, which are saved in IPython notebook files. Once you've set up a notebook, just navigate to that folder and type Jupyter Notebook to restart it. If you have other files, it'll show you a file tree like what's on the screen now, and then you can open the notebook by clicking on the IPython notebook file. So on to our first tutorial, web extraction with Selenium. Selenium is an automated testing tool that has a bit of an off-label use as a way to extract web data. Many people use it to scrape the web, but there are some trade-offs. It has to visually open each web page before extraction can occur, and depending on how many pages you're hitting, this can take a drain on your local computer. Your scraper will also likely break if page structure changes. But that's the case for many scrapers and is a difficult challenge to fully solve. Some of the pros of using Selenium, if you need a unit testing library as well, there it is. Also, it fully loads every page that is going to be scraped. So unlike other scrapers, you can actually interact with a web page programmatically. You can fill out a form, you can scroll, you can click, and so forth. If you head over to the PyPy entry for the Selenium library at the link that's on the screen right now, you can see that there are some dependencies needed to use this library. Depending on which browser you would like to use, you need a browser driver. In the case of Chrome, that's Chrome driver. In the case of Firefox, that's Gecko driver, and so forth. And again, you can find this information at pypy.org/project/selenium, and you'll likely need to download a proper driver version based on the version of the browser you have installed. It's basically going to interact with the browser through a Python script. Once you have your chosen browser driver installed, you can head over to your Jupyter Notebook. On my screen, you should be able to see a very basic scraper within a Jupyter Notebook. You start by importing WebDriver from Selenium. Next, you pass a few options. You can obviously find more options, a fuller range of options in WebDriver's documentation. But for our purposes, we want to see that the page is loaded, which we'll see through this headless bit. The page will actually open. We want to load a desktop size version of the screen in the event elements are excluded in mobile, or at the very least to make sure we're getting the same page we're looking at in our manual browser, which we'll use to locate what we want to extract. But truly the only important argument is driver.get. This is where you specify the URL you want to load. And that brings us to one shortcoming of some Python web extraction libraries. They aren't crawlers. So if you want to crawl many different pages, you basically have two options. You can loop through URLs and pass them into this get statement, in which case you may need a separate script just to find those URLs, or maybe use the sitemap or another spidering tool, or you discern the pattern in the URLs that you want, or so forth. The second option, which works for Selenium because it can interact with the page, is that of setting up a program that clicks through a site to deal with elements such as pagination. Before we get into that though, let's walk through our most simple Selenium scraper. Printing the page source method output of a driver is a great place to start. That can be seen here. This shows the HTML source code of the page and can be used to locate the elements you want to select and extract. It could be used to validate that you aren't blacklisted from a site, that the site is loading. Of course, you can also do this in Web Inspector, and I often find that I alternate between the two, but it's a good place to start. Let's hit run to return the raw HTML of our Manuka Honey page. And you can see the page is literally loading in a browser. There we go. So this is a great starting point, but we're going to want specific elements on the page. For this, we use driver find elements by CSS selector. So there's a useful rundown of all the ways to locate elements on the page with Selenium on this page that I'm looking at, the link below. But basically all you need to know is that you can locate elements on a page with Selenium using CSS selectors, with XPath, or with selectors for specific HTML attributes. It's also of note that there's a singular and plural selector of each type. The singular selector returns the first element that matches, and the plural returns the entire set of matching elements, as is often wanted with web extraction. For our Manuka Honey page, I'm going to grab the titles of products. Which if you head over to your inspector, you can notice are inside of a div with a class of product title. So if you were to print the output of these product titles in array of found elements based off a CSS selector, you might be a little bewildered by the output, which you can see here below. And that is because what you're looking at is something called, it's an array of WebDriver objects. You need to manipulate these objects to actually return the text value for each. And that's what the next part of this program does. We have a simple for loop. Simple for loop that dumps the text value for each WebDriver object into an array. And if you run the code, as shown, you should have an array of Manuka Honey titles printed to your output. Note that U followed by quotes means Unicode string in Python. So this is pretty cool, and you should be able to start to see how you could pull a range of values from our page, including pricing, review data, links to individual products, availability, basically anything you can find an HTML attribute that corresponds with the value that you want, or a CSS selector. But this also brings us back to the issue of Selenium not truly being a web crawler. Very few product index pages exist on a single page, so we're missing out on all of the additional Manuka Honey results. So how should we go about finding all pages with Manuka Honey on them? One of the most common ways is to find the last index presented in pagination. If you look at the Manuka Honey page, there are 3 result pages, and within the inspector, you can see that each unselected pagination link is in a element with a class of pagination link, as opposed to pagination selected, which is our current page. Jumping into a new notebook I've prepared, I want you to look at this new function called getPageMax. Basically, it's loading the starter page, and then it's grabbing all elements that are HTML elements with a class name of pagination link. This returns an array of WebDriver objects, like we saw in the last example. And then we use Python's negative indexing capabilities to get the very last object in the array. We pull out the text value, turn it into an integer, and it returns 3, the number of pages, the number of pagination pages we have. Note that I've also pulled out our product title extractor, and just imagine that you can iterate through similar queries to pull out pricing, reviews, many different fields. All you need is the CSS selector or XPath or HTML attribute. But for this example, we're just going to run with the product titles. And we pulled it out into a separate function so that we can call it with every single page visit. We can call it on pagination page 1, 2, and 3. We then utilize our number of pages to bound a while loop. And you can note that we've initialized our count at 1 because there is no 0th result page. So we'll be loading Manuka honey page, p equals 1, p equals 2, p equals 3. And getting data for each one. So if you click run, this should load an initial time to get our pagination links, and then 3 more times. And this highlights a definite upside and downside of Selenium. It does take time to visually load each page. Imagine doing that with 1,000 paginated pages or 1,000 paginated pages where you then proceed to all of the products on each one of the pages. It would likely take at least a number of minutes, if not hours or days. And utilizing best practices of spreading out your calls so as not to overload a site would mean it would probably take even longer, or you'd get blacklisted, your IP. An upside of using Selenium is that you can interact with the page. We loaded each page separately, but given a different layout, it might have made sense to click next several times, leaving the same browser window open. Either way, you can see the results of now our larger set of Manuka honey titles from 3 different pages. Now that we've walked through a basic scrape with Selenium, let's jump over to BeautifulSoup to examine a few of the trade-offs and see how we will accomplish this exact same extraction. So first you'll need to install BeautifulSoup, which can be done through a variety of package managers or by downloading a tarball and using the command python setup.py install. The only thing you need to be aware of is that you'll need to install a slightly different version depending on whether you're using Python 2 or 3. Really, all the details you should need are at this URL that we are on right here, that is included below. There are also options for utilizing different HTML parsers. For basic scrapes, this shouldn't matter that much, and choosing the optimal parser is really beyond the scope of this video. Just note that without installing an additional parser, that BeautifulSoup will default to Python's built-in parser. So as you can see, I installed BeautifulSoup and I initialized a new Jupyter notebook in a BeautifulSoup folder. Jumping in, we can see what an initial scrape looks like. It's a few lines shorter than the initial Selenium example, which is saying something as the Selenium example is pretty short itself, but it's just clear that BeautifulSoup is built primarily to load, parse, and pull elements from HTML. Whereas that's just one feature of Selenium, it's not its primary use. So jumping into this example, you start by importing get from requests, which is the standard way to get a URL in Python, and you import BeautifulSoup, obviously. BeautifulSoup does not visually load pages, so a quick check you can do is using get to load your URL and then using a text method to return just the first 100 characters. So most of these are white space, but you can see I had previously run this command and we see a doc type HTML. So we've verified that we are getting the web page, and I will comment that out for now. So BeautifulSoup essentially parses an HTML doc into Python objects, and there are 4 types of these: tags, navigable strings, comments, and BeautifulSoup. Tags are essentially HTML tags. Navigable strings are bits of text within a tag. Comments are HTML comments, and BeautifulSoup objects represent the entire HTML document. So there's slightly different methods for each one of these object types that you might pull out of a parsed page, but they almost all have to do with selecting a portion of an HTML page or specifying a unique element and manipulating the returned value in some way. So in our example, we take text from our response, which is basically our initial GET request with our URL, and we pass it into a BeautifulSoup object. Basically, this parses the page and saves the entire thing as a soup. That's what we're going to call it. And now we can use all the methods available to BeautifulSoup objects. Of note many times is find all, which can take CSS selectors to return a group of objects, very similar to what we did in our Selenium example. This is exactly what we do to return all items that are HTML elements with a class of product link. So note that the syntax is a bit different from Selenium, but it's actually, I find it's more flexible. You can pass in many attribute types to the bracketed second selector portion. So you can use find all in roughly this format for many scrapes, whether you want a title element or alt or the actual text value in between tags or what have you. And then in a simple for loop, we're just going to get the link value for each product link as well as the title. We use title here as the actual text for links on the Manuka Honey page is actually in another element. This is the div that we selected in our last example, but the text for each one of these is actually in the title of each link. So obviously, to make this extraction more usable, as well as the last extraction, you would want to map these returned values in some way, but that's really going to depend on your application. And if you need to look up how to organize and save returned fields in JSON or CSV or what have you, that's easy to do and beyond the scope of this video. For our purposes, we've returned slightly more data than the Selenium example in less lines of code. So what do we do about pagination here? As we've mentioned, BeautifulSoup is an HTML parser. It doesn't do anything to the actual page like Selenium. So there's no option to click through pages or submit forms, etc. One good thing about BeautifulSoup, however, is that it's good at showing dynamic or JavaScript generated content, and hidden elements are often presented in the HTML anyway, so you can grab those things. Our best bet is to use a process similar to our Selenium example. We can find all pagination links here in a get max pages function that starts from our initial crawl page. Our best bet is to use a process similar to our Selenium example. We can use find all to get all the pagination links and get max pages. See, we're getting all pagination links here. Use the same method of negative indexing to get the last value and return the max number of pages. And we then concatenate a count number that matches this onto our URL to get the values. So I've loaded a finished example in the browser, and besides slightly different syntax, the same logic pretty much applies as from the Selenium example. In the paginate function, and if you run it very quickly without actually having to visually load the pages, we have essentially an array of links and of titles that, of course, you could map together in some way. Of note are the facts that the process is largely the same as extracting data in Selenium, but BeautifulSoup is faster, typically takes less lines of code to achieve the same results. However, it can't interact directly with the page. We didn't need to do that in either one of these examples, but that can be a stumbling block for some web extraction applications. So now that we've worked through extracting our Manuka honey page in Selenium and BeautifulSoup, let's go check out how you achieve the same scrape using Diffbot's automatic extraction APIs. Of note is the fact that one key difference between Diffbot and either of the earlier web scrapers shown is that Diffbot utilizes AI to automatically detect page types and pull relevant information from them. This means that even when pages change or are dynamic, your crawler won't break. Diffbot has a series of APIs including article, discussion, product, and more. Additionally, a custom API allows you to specify exactly what you want selected based on selectors, similar to Selenium or BeautifulSoup. These APIs are utilized on top of Diffbot's service Crawlbot, which can automatically crawl entire domains or just selections of them based on crawling and processing rules. As we jump into our next Jupyter notebook, you may note that our setup looks quite different from either crawls. So you can head to diffbot.com to find our Python boilerplate and just clone the Git repo to get started. Then you'll need to use the command pip install -r requirements.txt in order to install all requirements. Of note is that Diffbot requires a developer token to utilize their automatic extraction APIs in Crawlbot. Luckily, you can sign up for a free 2-week trial at diffbot.com/get-started. Once you're registered, you can find your developer token at app.diffbot.com in the top right-hand corner of the screen. Just click on API token and copy it from the following page. You'll need to enter this into config.py, which is in the boilerplate. So jumping into our main example, Jupyter Notebook, let's take a look at how to get started crawling in Python in Diffbot. So if you've installed the boilerplate, much of this will be preset. Essentially what we're doing here is we're adding parameters to a URL that we're going to send a post request to. Working through the parameters, we have our Crawlbot endpoint, which is where we'll send their request, and our API token that we have imported from our config file. Next, we have a name for our crawl, which I've given name of this crawl Manuka. And then we have our seeds. In this case, we have one seed URL. These are the URLs from which we'll start crawling. A crawl unlimited by crawling patterns or maximum hops value will follow every link it could find on a given page, and then every link from every ensuing page. So the crawls can get quite large, particularly with many different seeds. And in all likelihood, they will eventually reach every page that's linked to on a site. In our case, we don't want to crawl the entire site. iHerb has at least hundreds of thousands of items, and we're primarily looking for getting information on Manuka honey. So next is the API we're going to parse each page with. We've chosen the product API. Then we have max hops, which specifies the maximum crawl depth away from the seed page that is allowed. In theory, if we've set up our crawl and process pattern parameters correctly, we shouldn't need this here, but because iHerb is such a large site, and our crawl pattern may inadvertently enter pages we aren't interested in. Say a blog post that also includes Manuka, or a press release, or so forth. And so I set it to 2 to cover our 2 pagination pages that we need to click through. Next comes crawl pattern and process pattern. So we don't technically need process pattern here, as I'm specifying the exact same values, and leaving process pattern unspecified would mean every crawled page will be processed, but I just wanted to show it for illustration. And the difference between crawl and process pattern is that crawl pattern can be used to specify which pages to crawl or not to crawl. This can stop a crawler from reaching entire sections of a site. Process pattern specifies which of the crawled pages you would like to process with your selected extraction API. So if you take a look at the Manuka honey page, note that each pagination page has a P equals in the URL. And then also a quick survey of the Manuka honey product pages. They each have a /PR/ value in their URLs. And all of them that I have seen also have the word Manuka in their URL. So that's a bit of what we are doing with crawl pattern and process pattern, is we are specifying only crawl pages that have Manuka or P equals or PR in the URL, and only process those that match the same rule. So essentially, we're wrangling the crawler to visit pagination pages and all individual product pages for each Manuka honey entity. Finally, use canonical specifies whether, in the event there are two versions of a page, with one specifying another as the canonical page, you should only use the canonical page, whether you should only process the canonical page. I've tried this crawl both ways, and in this instance, it doesn't change the outcome, but I've just included it so you know about the parameter. Basically, 0 specifies canonical status doesn't matter, or processes all pages that match the processing pattern, and 1 means only canonical pages are used. So then after we concatenate all of these values onto the end of our endpoint URL, we essentially are just using the default requests library that comes in Python to send a post request and printing the response. So if you click on run, you should see a message about how your pages have been added for spidering. Diffbot's Crawlbot is extremely powerful. It can crawl sites with hundreds of thousands of pages. So just getting a response for now lets us know that the crawl has at least begun. While you can load the data that's returned from your notebook, it's often a lot of data. And I want to show you another way to retrieve your data that gives you a few more initial exploratory options. So I've headed to app.diffbot.com, which if you have a trial account or a paid account, is our main login for all of our products. And then you just need to click Crawlbot, all crawls. You could see the crawl that we registered, Manuka, and that it is in progress. So as of now, it's crawled 275 pages and processed 174 of them. And that is orders of magnitude more crawling than our pagination example, with arguably less lines of code than either of the other libraries if you discount the boilerplate. So let's check out what the data looks like. You can click into your Manuka crawl. Note that you can open up your data in JSON or CSV. You can also right-click and save link as, which will download the JSON. So I'm going to Control F for Manuka. It looks like there are 1,628 references to Manuka in the return data. I'm going to guess that our processing patterns weren't quite stringent enough, and I could see skimming through here that within 3 hops of our seed crawl, other pages did have Manuka in their title. Like I saw a press release, blog posts, but we also returned entries from our product pages. So Diffbot's AI is honed to pull all sorts of data from product pages, particularly when you point this automatic extraction product API at them. You could see fields such as offer price detail, how much it costs, what the nutritional data is of these Manuka honey products, what its dimensions are, what its weight is, what its shipping weight is, obviously the URL, a text write-up of what it is, its availability, and a number of other fields. So, whoa, that is a ton of data, and all done in less lines of code than either one of our previous examples. So there are certainly trade-offs, as Diffbot is in the end a paid subscription service, but if you're looking to power an app or a dashboard or support some series of market research or a crawl at scale, there's truly no comparison. Besides specifying what pages we wanted to be processed, there was literally no extraction rules required, and even fields that weren't visible on the page, such as availability. So we wouldn't necessarily be able to find these by manual research, short of trying to order the product, were returned in this data. So yeah, to recap here, some of the pros and cons of two of the most popular roll your own web extraction libraries in Python, and then for comparison, the use of one of Diffbot's automatic extraction APIs. And I would say if you're going to be trying any of these out, or even if you have a one-off project, the Diffbot API via Python is definitely worth a try for the free 14-day trial. You can likely get a treasure trove of data even in that amount of time, or at least really be able to verify its value. So one final note, I wanted to touch on best practices for web extraction. These are important and should feed into what web data extraction method you use, which sites you extract from, and how you implement your web crawling. So number one, obey robots.txt. This is a file every site should have that specifies which crawlers are allowed. Oftentimes, it notes that all crawlers are allowed. And many times it specifies one or two that aren't allowed. And it also specifies if there are any special rules, such as a delay for crawling you should implement, or a part of the site not to crawl. Bot traffic makes up a large portion of web traffic these days, and sites are responding in kind from the load that places on them. While a site owner likely wants to be crawled by Google, another bot tanking their bandwidth or their bounce rates or leaving spammy comments or just flying through their site again and again probably isn't welcome. So as you can see, I pulled up iherb.com's robots.txt file, and let's take a look. So on the top line, you can see that this set of disallowed URLs are applied to user agent all. That's what the asterisk is. So basically, they don't want any crawlers to visit any of these pages. You can note that the pages we crawled that had /PR in their URL for product pages or /C for category pages are not on this list. So they are all right with entities crawling those pages. You can also see at the bottom that MSNBot has a requirement to have a 2-second delay between their crawls. So maybe MSNBot was spamming iherb.com at one point. Maybe they noticed this and they clarified their policy. So on to the next best practice in web extraction. Number 2, do set a delay for your page crawls. If you misconfigure a crawler, you can ping a domain again and again and again at a speed that is only possible programmatically. This is a common courtesy to set a delay, as well as a good practice to not get your IP blacklisted from visiting a site. Third, very similar, don't crawl again and again. Discern how often you really need to crawl. For data that truly needs to be live, there's likely an API that can give you your results more quickly. Fourth, don't crawl during peak hours, particularly if your crawl is disobeying one of the last few rules or visiting a ton of pages or so forth. Crawl in the middle of the night or early morning for the site's early audience or something like that. Finally, be aware of proxies. Proxies allow you to mask your IP. They can simulate visiting from another nation or continent, which can change the content provided to you, and they can keep you from getting your IP blacklisted, which can happen even if you're following all of the rules we've listed. So one difference between these 3 web extraction providers is that Diffbot does come with proxy access, and you can but you can also configure your own. For the other providers, it just adds a whole level of complexity to your project. And if you're going to be powering an app or a dashboard or a mission critical application with your crawled data, you're going to want to make sure that you aren't just out of the blue when you need the data most blacklisted. So that's it for today's video. If you thought this was informative, please like and subscribe, and let us know in the comments what you want more web crawling content of in the future. Thank you so much.